Hey, hold on. Say it again. There was a lot of math that went into this, and I'm going to try my best to explain it all to you. So potential energy is the energy an object has due to its position because of gravity. So the higher something is in the air, the more potential energy it has. And as it falls, that potential energy turns into kinetic energy. So the potential energy at the top equals kinetic energy at the bottom. So potential energy is equal to mgh, and kinetic energy is equal to 1/2 an object's mass times its velocity squared. So because those things are equal, you can cancel out the masses on each side because it's the same for the object. And then you multiply both sides by 2 so that you have 2gh, and then square root both sides, so you have v equals the square root of 2gh. Then we substitute in the 2 times the acceleration due to gravity, which is 9.8 meters per second squared, times the height of the hill above the jump, which is 2 meters. Then we solved that for that, and the velocity that it took off from the jump was 6.2 meters. So when you put that into a triangle and solve for the velocities in the x and y direction. So that to solve for it in the x direction, you would do 6.2 times the cosine of the angle, which gives you its horizontal velocity, which is 5.8 meters per second, and then 6.2 times the sine of the angle, which was 20, is 2.1 meters per second. So then once you've done that, you can, this is all to solve for how far the landing should be away from the jump, by the way. You would use the equation Vf squared equals Vi squared plus 2 times the acceleration due to gravity times the distance that the object fell vertically. So this is velocity in the y, so it's 2.1 meters per second squared. There was no velocity initial because it would be that's like velocity, and it's for falling. So when an object's at its peak in flight, the velocity initial is 0 because it's not moving with the y velocity, only in the x. So as it will accelerate down to 2.1 because that's the speed it took up from, because trip up equals trip down. So then you just have the 2 times the acceleration due to gravity times the distance. So 2 times that, you do the math pretty much there, and solve for d, and it equals 0.11 meters. So then with that you plug into the formula d equals VIT plus 1/2 GT squared, and that's 0.11 meters equals 2.1 meters per second times time plus 1/2 negative 8.1 meters per second squared times time squared. So you solve for the half time because that is still only tripped down, and since it goes up and then down, you have to multiply by 2. So it's 0.6 seconds that the bike is in the air. So since we know how fast it's going in the x direction because we solved for it over here, we can multiply that by the time that it's in the air, and that is how far it should go, which is 3.4 meters. Now obviously, as you can tell in the video, it didn't go 3.4 meters, but that's because we treated it as though it were a perfect world, and there is very little friction because the object is rolling, but the sand beneath and dirt beneath the tires moves around, and we lose a lot of energy because of that. So friction, heat, and sound, and the deformation of the sand, we lost a lot of energy. So we didn't quite go as far as we should have, but we did our best. So we were close, but not perfect. But in a perfect world, you would land exactly 3.4 meters from the jump. The end.
That was pretty good. You missed the landing.
I missed it.
Despite our best efforts, we did not end up going as far as we were supposed to. We went maybe 2 meters instead of 3.4. If it's because a lot of energy was lost moving the soil around as the bike traveled down the hill. If we had done this on pavement, it would have been much more accurate. That would have been a really good idea, but we didn't have a jump to put at the end of a paved hill. And if we did it on snow, we could have solved for the friction, and that would have been really accurate too. But it didn't snow this winter, so we couldn't do it with skis and snowboard. That would have been a lot better. But this was actually a lot of fun to do, so yeah. Take physics.